Just some more 96 Cell LTO updates. So I did bother to put a piece of perspex on here. I had a small piece kicking around, so I just cut it down to size to cover that and to cover the connections at the end here. So that's if there's any movement there and it fell against the switchboard, then you wouldn't get a short circuit. So that just makes that a little bit safer. You'll see there's some few extra components on the end here, and we've got a 70 amp relay here which switches the output of the Meanwell DC to DC PSU. Basically it disconnects the PSU from the 12 volt battery when the car is off. So this relay is operated by the ignition, so whenever the ignition's on, this relay, the relay is active and the PSU is connected to the 12 volt battery. That's because the Meanwell has a parasitic load, a small load, so if you were to leave it permanently connected to the battery, then it would slowly discharge the 12 volts. So that's why I've included this 12 volt 70 amp relay here. It's got a flyback diode to prevent back EMF, and it's actually wired into the original DC to DC converter switch. I've also put a resistor across the temperature sensor here to give a fake 10 or 15 degrees centigrade DC to DC temperature. So this will just plug into the normal harness, and there's an ignition switch 12 volt supply into here. So that's the DC to DC basically all done. That's all ready to go back in. I'm waiting for the capacitors to arrive for the snubber unit. This is an identical snubber unit from the 12 volt, from the switchboard. This is the one which on the actual car I think has got a problem, but it's really raining heavily today. My car's outside, so I'm not going to go outside and start taking this off the switchboard today. It's going to get soaked. So when the capacitors arrive later on, what I'm going to try and do is when I get the faulty one off, or potentially the faulty one, I'm going to try and take it to bits, dig out all this and basically make up another little board to fit in here with some modern brand new capacitors in, so the same rating. I have tested all these for capacity on my multimeter just as a matter of interest, and these do give 0.1 microfarad capacity, which is as expected from what is written on them. So yeah, so basically I'm going to rebuild this and then fit it, or rebuild the faulty one and fit it to the switchboard. Now there is one of these on the IGBT in the MDM, but that's not throwing a fault at the moment, so I'll leave that alone for now. But if it does go faulty and the high voltage short circuit code returns and it's not this one, then I'll take the one out of the IGBT module, which is on the other side of this. So in fact I'll just put this down, which is in here, and I'll replace it with one made with new capacitors. Anyway, so the only other thing I'm doing now is I'm looking at the inside the MCM. This is a spare NTM I've got, but it's virtually very similar to the one that's in the car at the moment. But this one is going to have the switched 120 volt, fixed 120 volt mod for maximum power. So this is going to give us even more power than you saw from the current videos, where I was getting an easy 20 plus kilowatts. So this will fix the V-pin voltage and the BCM voltage at 120 volts, which is basically where the minimum the car will allow for maximum power. So this will be 120 volts. The car will think it's 120 volts when this is activated. It's activated via the IMAC P&P with a special data code coming from the OBD2 CNC when you put your foot down. So this will then switch this. The voltage will be fixed at 120 and the current will rise by another 30 or 40 amps or so, which will give us another 5 or 6 kilowatts. So that'll be about as absolute maximum that I can expect from the system. But that will only be active in wide open throttle, and I also shall set an RPM limit so that it only comes on once it's into the sine wave zone. So this will be sort of like a second boost. So you'll get your first boost when you put your foot down anyway, because you've got the 40% current hack and you've got the wide open throttle mod on the IMA CNC, etc. But once the RPM rises above I don't know, 2000 or whatever it is, wherever the switch point is, 2500, then this will activate if you've still got your foot on the throttle wide open, and this will bring in your extra current when the IGBT is in the best state to accept and deal with it, and that'll be about as much as we're going to get out of the IMA system. So yeah, I'm going to probably remake this little board just to do some better isolation for the higher voltages that are involved, and I'll have to bring the HV in here into this switching board, and then it'll have to go out to the BCM fooler and it also has a V-pin connections here. So that's where we are. So tinkering around because it's lashing down with rain, waiting for the capacitors to arrive, fiddling around with the DC to DC, get that how I wanted it, and we've now got that bolted on with the safety insulation sheet, with 70 amp relay to cut the Meanwell off when the ignition's off, so it doesn't parasitically drain the 12-volt battery. So yeah, that's all basically ready to go in. So all I need to do now is I need to connect the negative from the 12-volt battery to this, and the positive will go onto one of those big spade connectors here. I'll just put a little adapter on the end of the 12-volt ring terminal lead that normally fits here, or I might actually drill a little tiny hole in that and just bolt it to that, screw it to that in fact, and then cover it. So yes, it's all very solid, not going anywhere, and that's all ready to go back in the car.